So we now know about limiting reagents and that they're going to limit the amount of something that we can produce. But up until now, we have assumed that we are going to have all of our reactions go to completion. That is, that we're going to use up all of our limiting reagent in doing this. The problem is that this is rarely, and I'm actually going to put in parentheses here, never true. The degree to which conversion occurs is measured after the reaction is complete, and basically reactions pretty much never actually go all the way to the products. There's always some amount that doesn't react no matter what, and the reason for that really can vary according to a lot of different variables. It would really be kind of unrealistic for us to expect that we could get every single molecule to react. So we have to live with the fact that conversion is not complete, and we need a value to kind of measure this. So we express the amount of conversion that we have as something called our percent yield. And the percent yield is going to be the actual mass of product that we produce divided by the theoretical mass. And the question you might have is, what exactly is our theoretical mass? Our theoretical mass is exactly what we've been calculating so far. The theoretical mass is the mass that you should get when you've identified the limiting reagent and gone through the calculations to figure out what mass you should get if you had 100% completion all the way to products. It's important to note that you can use mass here, but you can also use moles, and I will leave it to you to double check this. But if you convert both the values to mass and do mass divided by mass and multiply by 100%, and then you convert them both to moles and do the same calculation, multiply by 100%, it's in fact the same number. So let's take a look at an example. A student identifies the limiting reagent in her reaction and calculates that she should theoretically be able to produce 23.17 grams of product. When she weighs her final product, she has 21.78 grams. What is her percent yield? So we have our theoretical that she calculated she should be able to get. When she went and did the reaction, she actually got a little bit less than that. That's to be expected. We'll take that actual yield, 21.78, we'll divide it by that theoretical. We multiply it by 100%. That's going to equal 0.9400 times 100%, or 94.00%. Now, I do want to mention that here we kind of skipped over how we got to this because we've already done a lot of examples. Our limiting reagent example, for instance, and our stoichiometric factor examples, where we have one that's in clear excess to figure out what mass we should be getting based on what mass of reagents we have. When you do your homework, however, they're not going to be nice when they do this percent yield. They're just going to ask you for the percent yield, and you're going to have to go through all the calculations to figure out your theoretical mass and then do this calculation in order to get your percent yield. They're not going to ask them as different questions, but instead jam it all together, and I want you guys to be prepared for that. Let's look at one other example of percent yield type question. So a typical percent yield for a given reaction is 96.86%. If a student calculates a theoretical yield of 2.053 grams, how much actual yield should they expect? So if it was 100%, we would get 2.053 grams, but it's not. It is 96.86%. So we'll take that theoretical yield, we'll multiply it by 0.686. Remember that you don't multiply directly as a percentage, but instead convert that to a decimal here. And we'll see that we could get an actual yield of 1.989 grams. And so what we're doing here is we're taking our theoretical yield, this number here, we're multiplying it by this ratio here, actual yield to theoretical yield. And so that cancels our theoretical yield and leaves us with just our actual yield, which would be this value here.